Hello everyone, welcome to another video for the day 3 problem in 30-day lead coding challenge. And the day 3 problem is maximum subarray. So basically the maximum subarray will be like if you will be given an array with numbers and you have to find the subarray within the array in such a way that it has to be contiguous and the sum has to be largest. So whenever you find the subarray with the largest sum, you have to return that value. So that is the objective for this maximum subarray problem. So and there is a follow-up. So the follow-up says that if you have figured out the O of n solution, try coding another solution using the divide and conquer approach, which is much more subtle. Okay, so if your time complexity is O of n solution, then they're asking to go with the divide and conquer approach, maybe something like a merge sort. So that is something which we can try it if we have more time to solve on this problem. Okay, without any further delay, so let's get into the solution. So for maximum subarray problem, so whenever you see this maximum subarray some kind of problems, so most of the times there is one algorithm that works out. So that is Kadane's algorithm. So this is something which is pretty famous for this kind of problems. So there will be a lot of tutorials and implementations available over the internet. So you can actually have a look into it if you are listening this name of the algorithm for the first time. All right. So let's get into the implementation. So I am going to declare two variables, which is max so far. So the max so far is a variable which keeps track of the sum value, like what is the. So when you are actually iterating over the array, you will be coming across different sum values. So if you go with a brute force approach, you will find a lot of sum values, and from overall sums, you have to pick the largest sum. But as we are going with the cadence algorithm, we are going to iterate over the entire array once, and we will go and by using this algorithm, we are going to pick the largest sum. So for max so far, we are going to use the max int. So max int is something which is a variable available in the sys package. So for this, in order to make it feasible for all the negative numbers as well, I am going to declare it as minus max int minus 1. Then I am going to declare max ending variable. So this will actually keep track of what is the subarray length that we need to consider for getting the largest sum. So max ending array deals with the subarray start and ending points. Max so far deals with what is the largest sum that it has been came across in the loop. Okay, so here we have initiated the for loop. So in the for loop, first we are going to start with max ending. Here we are going to look at what is the max ending here for each element. So this will provide me the max ending here value, which will actually calculate by picking the maximum ending array and the each element from the array index using index. Then once you get the max ending here, you can check if the max so far is less than the max ending. If the max so far is actually less than max ending here, you want to update it as it has found the largest value than the earlier one. Once you do this, then you may actually have to update the max ending here as well to 0. Why are we actually updating the max ending here value to 0? Is just because if the value is less than 0, you may want to update it to avoid the unapproximate value when you are trying to add it with the element in an array. So that is why you are trying to update it every time to 0 if the max ending here is negative value. However, a negative value cannot be the largest sum if there is a mixture of positive and negative. If there are only, let's say if you have, if the input is only negative numbers, then at that point of time as well, updating to 0 will help us to be more accurate, getting the overall largest sum value, overall the bigger number within the all negative numbers in the array. If that is the case, so here once you have done this, you are going to return the max offer. Let's submit this solution. Submission has been accepted. Let's see how good our approach is. And meanwhile, you guys can actually try how can we implement the divide and conquer approach rather than the solution that I have shown here. So our runtime beats 60% of Python submissions. So I believe there is much more left where we can actually improve this solution. So I'll post the efficient one in the upcoming videos for the same problem. Hope you have understood the implementation. If you have any questions, comment down below. And if you are visiting for the first time, please subscribe to my channel, turn on the notifications. And thanks for watching. See you next time.